Alright, so this is going to be on lesson 2.1. Alright, so the do now says describe the car's motion in the GIF. So if you look at the car's motion, you can see that, well, it's slowing down as it gets towards the tree. Well, but then here's the thing, right? Well, why? Why do we know that it's slowing down? Well, the key here is that, well, if we take a look at each place the car stops, right? So the car is initially stops there. Then the car stops over here, right? I think, well, I'm just estimating right now. So where's that? Yeah. So it stops over here. Then stops over here, right? Over here and over here. So clearly, you know, right? Your brain knows that, well, if my car travels less distance each second, we know we're slowing down, right? And that's extremely important for us to figure out. Well, is it speeding up, slowing down, or traveling at a constant velocity, right? So this is extremely important, right, in explaining why something is happening. And so we come to this first image. Now, on your notes, right? So on your notes, remember, you do have on your notes, right? So on your notes, you do have a space to circle it. So I ask you guys on your notes, well, describe the motion in this picture and to draw a dot diagram of the motion. Well, first we're just going to describe the motion of this object. And just to give you a brief intro, right? So this is a picture is taken of the same object once every second, or rather once every time interval, right? So a picture is taken at equal intervals. And then once all the pictures are taken, all of them are shopped onto the same picture, right? Photoshopped or combined together onto the same picture. And so this is what you get. So the object is going from left to the right. It's going from left to right. And so our job here is to see, well, what was the motion of this object? Well, if you were to draw a dot diagram again, well, let me draw it up. Yeah, I'll draw it. Use a darker color, I guess. Or lighter color. That's fine. So if we were to draw a dot over each object, if we draw a dot over each object, right, if we draw a dot over each object, well, each time interval, right, we can see that the object is traveling an equal distance each second. And so this is our dot diagram. This is our dot diagram. Well, this is a bit off, right? But that's just due to human error. So you travel an equal distance each interval. So you know the object is traveling at a constant velocity, right? You know it's traveling at constant velocity because you see that the object travels an equal amount of distance each interval, each time the picture was taken. So let's take a look at this one. Let's take a look at this cart right here. All right. So, well, if we were to draw a dot diagram, so we're drawing a dot diagram right here, right? So this is a cart, right? This is a cart, and those blue lines indicate where the cart is. This is a track too, by the way, if you've been in lab. So if we were to take the distance between these objects right here, right? The distance between these objects right here, well, you know that the distance is increasing each time interval, right? Each time a picture is taken, you see that the distance increases. And so we can say that this object is speeding up. right? We know the object is speeding up because the object keeps traveling a greater distance each second. So we know the object is speeding up. Do this. Do this one. So if you can't quite clearly see it, it's a box, right? A box is being dropped. So there's a box here. There's another box here the next second. Right here. Right here. And if you were to draw the dot diagram, right, you see that the distance each second, each time the picture was taken, you can see that you're speeding up, right? The box is getting faster and faster and faster. So your object here is speeding up. And if we go to 1D, go to 1D, let me take a picture of it. So 1D shows you a picture of keys. Alright, so 1D shows you a picture of keys. Going from left to right. So if we were to draw a dot diagram of these keys, and again, someone's sliding it on the table. If we were to draw a dot diagram on these keys, you can clearly see that the object is slowing down. Right? You see that as you go from left to right, that the distance traveled each second is decreasing, which means you are slowing down here. Right? You're traveling less distance each second. So you are slowing down. Now, this slide, constant velocity again. So we're on number 2. We're on number 2 now. Let's say your velocity is constant, right? And what does constant mean? Well, constant means you're pretty much the same, right? Same, not changing. It's constant. So if I say constant velocity, it means your velocity is not going to change. It's going to stay the same. So now, and what my velocity means, right? So velocity is meters per second, right? That's how we measure velocity. But what does that mean? Right? What does that mean for velocity? Well, look at the unit, right? My velocity is meters per second. So every second I'm traveling a certain amount of meters, right? We take a look at this unit, right? Velocity is meters per second. Well, then this means that every second I travel a certain amount of meters. Right? Because that's what velocity is, right? It's meters per second, or well, every second I travel a certain amount of meters. In this, I'm gonna erase this actually. In this diagram right here, we're traveling 5 meters per second, right? We go from 5 to 10, which means we're traveling 5 meters per second. So every second we're traveling 5 more meters. And so our position at the second is 15, and our position at the third second is 20, because our velocity is 5 meters per second. Each second we're traveling 5 more meters, right? Because that's what velocity is, and that's what velocity is. Go to the next one. So now on the second slide here, we're still at constant velocity, but we're gonna have something different. So we're gonna start on the right hand side and we're gonna move to the left. So now we have a negative velocity. So we have a negative velocity here. So how many meters per second is this toy car traveling? Well, we're going from right to left now, right? So we're going from right to left because the time is equal to 0 on the right hand side. So at a time of 2 seconds, we're at 15 meters. 3 seconds, we're at 10 meters. So what's my velocity? How many meters per second am I traveling here, right? Every second, how many meters am I traveling? Well, you see your position decreasing. So you can say, well, my velocity is negative 5 meters per second, right? My position changed by negative 5 each second. So my velocity is negative 5 meters per second. Meters per second, guys. Meters per second. All right. Moving on. So now we're going to work with constant velocity. We're going to work with constant velocity now. With constant velocity. So now acceleration is the same thing, really. Right? Acceleration is for the most part the same thing. I'm going to copy paste this entire thing actually. Velocity is pretty much the same. I mean, acceleration is pretty much the same thing. Except acceleration, and I write this on your notes, right? Acceleration is the change in velocity, right? That's the literal definition of acceleration. So acceleration is the change in velocity over time. So your acceleration measures how much your velocity is changing per second. Let's take a look at this diagram, right? Let's take a look at this table, rather. My velocity is changing in 1 second from 0 to 5. If my acceleration measures how much my velocity changes each second, then what's my acceleration here if my velocity went from 0 to 5? Well, my velocity changed by 5 meters per second in this second. So my acceleration is 5 meters per second squared. Now, so again, this unit right here is meters per second, right? Because that's why it's squared, right? My velocity changes by this amount of meters per second every second. So if my acceleration is 5 meters per second squared, that means my velocity changes by 5 meters per second every second. And if my velocity changes by 5 meters per second every second, well, what's my velocity the next second? Well, you add 5 more meters per second, you get 10. If my acceleration is still 5 meters per second squared, well, my velocity is now 15. Thinking about it a different way. Thinking about it a different way. Let us say, I don't know, my velocity is 5 meters per second here. Right, let's say my velocity is 5 meters per second here. And what I'm about to say right now is not not correct in real life, but I am doing it to show you what essentially I mean, right? It's just to make it easier for you to understand what's going on. Again, this is not true for real life. So let's say in the first second, my velocity is 5 meters per second. What is the length I travel in that 1 second? Right? Because if my velocity is 5 meters every second, every second I travel 5 meters, then what is the length I travel in that 1 second? I travel 5 meters. Now we're gonna move on, right? And then now our velocity here is 10, right? 10 meters per second now. And from 1 to 2 seconds was the distance I travel with my velocity is 10 meters per second. Well, then the distance I travel is 10 meters because my velocity is 10 meters every second. So every second I travel 10 meters. And we move on, right? We move on, and so my velocity here is 15 meters now. 15 meters per second. Just changing the color, right? Just changing the color. So this is 10 meters. So D is 10. D is that. And so V, right? So if our velocity is 15 meters per second, well, now I travel a distance of 15 meters. And again, I'm saying this is not entirely correct. It's not how it works in real life, but I am simplifying it for you just to make it more intuitive for you guys to understand. And this is fine so far, right? Because if your velocity is 5 meters every second, then you travel a distance of 5 meters in that 1 second. Well, let's take a look at A. Well, how does A fit on all of this? Well, A is how much your velocity changes each second, right? So my velocity changes by 5 meters per second squared each second. And the same thing over here. 5 meters per second every second. And so you kind of see how it branches out now, right? So we go from D to V to A, right? It keeps going down. V is how much D changes. A is how much V changes every second. So this is kind of how it goes. So now let's do the signs. So the sign of my velocity is positive. The sign of my acceleration is positive. So the type of motion that we're seeing here is we're speeding up. All right, let's move on. This one. So again, your acceleration is how many meters per second you change per second. In other words, how much does your velocity change each second? Well, if I go from 20 to 15, how much does my velocity change? -5. Feel free to participate, even if you're just watching the video. Feel free to come up with an answer before I even give the answer, right? It's to help you confirm what you're thinking. It helps you become as much of an active learner as you can be by watching a video, right? But try to be more active when you are watching this video. So if my velocity changed by -5, well, what's my velocity the next second? 10, right? Which means I'm getting slower now, which you do see here, right? You're getting slower. Velocity is 5 here now. So the sign of my velocity is positive, sign of my acceleration is negative, which means I'm slowing down. Opposite signs means you slow down, right? Because which we will learn. All right, let's do the next one. All right. So let's take a look at this. How much does my velocity change each second, right? So my velocity goes from 0 to -5, so -5 meters per second squared. So if my acceleration is negative 5 meters per second squared, my velocity changes by negative 5 each second. Go that. So the sign of velocity is negative. Sign of acceleration is negative. That means we are speeding up. By the way, at this point, you're probably like, well, that doesn't make sense. It's negative. Why does it mean we're speeding up? Well, the negative sign, if you watch the prior videos, if you haven't seen me explain this. So your negative signs. Your negative signs really just mean the opposite direction of the positive. And so here, they just mean left or south, right? They only mean a direction. Your negative signs in physics only mean direction. In math, you're taught that, well, negative signs means decreasing or lowering, but in physics, your negative signs means opposite direction or the negative direction. So that's that. Again, you have to dispel your what you learned in math, or rather the negative signs in math, because it means something different in physics. All the negative sign means is your opposite direction, right? So this plane is traveling to the west, so we can say it has a negative velocity, and because it's speeding up, it also has a negative acceleration. Okay. Now, how much does your velocity change each second as you go from negative 20 meters per second to negative 15? Again, we're going this way, right? And we're actually, if you take a look at the diagram, we are slowing down. So how much does your velocity change each second? So it changes by +5. So again, positive is not a direction, so we have to write east, right? So +5 gives you that. And now your velocity is -10, -5. So with the sign of velocity negative, with the sign of acceleration positive, and that means because we have opposite signs, we are slowing down. Okay. Now the next question is, what is a general rule you can make regarding signs of velocities and acceleration when speeding up or slowing down? All right, so if you take a look at this, actually I'm just going to give you it, right? Think about it. If you're speeding up, you must have the same signs for both velocity and acceleration. If you're slowing down, you must have opposite signs for both velocity and acceleration. So if you look at this GIF right here, you can see that, well, if you're speeding up, you have negative velocity and negative acceleration, or you have a positive velocity and a positive acceleration. If you're slowing down, you have a negative velocity and a positive acceleration, or vice versa, positive velocity, negative acceleration. Right? Okay. And then do your homework, right? Your homework is a Google form.